All right, so what I want to do, I'm broadcasting this early, um, and it'll show up in your list. But what I want to do is I want to get in and deal with this first. I'm going to deal with these terms, and then what I'm going to do, I'm going to give you information on how you deal with the I want to basically deal with the parallel access theorem later. So right now, I'm going to basically look at these terms. I'm going to go ahead and pick a problem that you will see here in the near future. And I'm going to basically start by integrating, let's see, you got to be real careful here. Which one is being asked for? This one is I x. Now, usually I write two x's. He'll write one, but that's okay. So essentially, it is the moment about here. So I like to think of it as the object is spinning around here, and this I is kind of like an inertia. So, but the term just looks like this. Okay. Now, in this particular case, again, I like to do them this way. Okay, dx dy, or integration of y squared dy dx. Okay, this amounts to the simple thing we talked about in class, which was we have a thing which is dx and dy, and essentially, how do we want to run this thing? Do I want to run it vertical and have, start down here? I didn't pick up the D, sorry. Here. What's going on here? Up, up, up. Okay. So the question is, do I want to sweep these to the left and right and move them up and sweep them to the left and right? So let's assume, so we'll just put it right here. Let's assume first, or let's just move it off the chart here. Let's assume first we're going to sweep this way, and then we're going to come back and sweep again. We're going to sweep again. So I'm sweeping my dx and dy, little d areas like this. If I'm doing them like this, then you'll find the left boundary here, and you'll find the right boundary here. How far do I sweep them to? All these sweeps started from here and went all to here. So this is basically, this description is this one. So let's start with that one. Okay, so here's the equation of the line. Okay, so first I need to, let's do this and move these a little further out. And maybe I need to move this back a little bit as well. Here. So I'm sweeping from the left end, which is this curve. And I'll go ahead and admit the right end is pretty easy. It's just one. But the left end is a curve, which that curve, of course, here's the equation. But I'm sweeping that curve from x, y to the third, and halves. So if you either got that or the other, so y to the 3 halves, and then how far am I sweeping this thing from? 0 to 1. Now, what I'm going to do is I'm going to make use of the code I talked about before. Okay. Okay, I'm moving really slow for some reason. Okay. Yeah. I know. Okay, here. So the first thing I'm going to do is integrate that center section. Now, I'm not sure I'm right or wrong here because I'm just doing this as it flows out. So I'm integrating an expression y squared. My variable of integration is x, and I'm integrating from, okay, y. Okay, I'm having trouble reading the keyboard. 3 divided by 2. And then yeah, that's where I'm integrating from. Now watch what happens. Oops. I did that again. Okay. I need to watch that because he closes the parentheses for me. Okay, I get that. Now I'm going to integrate that with respect to y from 0 to 1. Hang on. I'm going to integrate next the previous value from 0 to 1. And I get 1/9. So this tells me that I get 1/9. Is that true? But let's say we do this. Okay, so here in this process, let me move this up here. I'm going to see if I can take the picture, and I'm going to shrink it down and move it down. Oh. See, copy, paste. Okay, now X. I did a copy, right? I'm going to go down here, paste it again. This time, I want to do it a little different. I want to sweep this way. So I'm sweeping this way. Notice my variables inside my first integral are going to be from here to here. So what am I integrating? Okay, let's see. I've got a y squared, but I'm doing dy first, and then I'm doing dx. So my y's will sweep. Okay, let's take this equation. Y is equal to x to the 2/3 now. So I'm sweeping from 0, the lower integral, to this upper integral, just x, hang on, to the 2/3. And my little sweep lines start here and go all the way over to there. Now, oops, sorry, squared. Okay, so now, here we go. Let's move that down to the bottom of the page. I'm going to go to my maxima again, and I'm going to put in a new integral. I'm going to integrate an expression which is y squared. The variable of integration is, of course, y. I'm going to make it a definite integral. I'm going to go from 0 to x to the 2/3. Okay, there's where I'm getting a problem. Okay, I don't need that extra parentheses. It puts the parentheses there for me. So I integrate, and it's back up here. So now I want to integrate that. Okay, so what happens is, okay, so let me fill in the gaps here. So this integrates out to give me an integral from 0 to 1 of, okay, x, okay, what the heck was that? X squared over 3 dx. So give me the same thing. How do we do that next phase? We go in. We want to do integrate again. The percent means take the last expression. We're integrating it from 0 to 1. And guess what? You get 1/9 again, which that's the answer. So, I know in the book he has some interesting ways of doing things, and that's great, but we don't need to make it more complicated than it actually is. So let's go and do one more problem, and you'll have to give me a moment to kind of find it. I'm on another screen here. So let's see. I'm going to step through these one at a time until I can find my... Oh, well, I guess I could do the other thing, and that is this. Let me do this real quick. Okay. So now, instead of finding XX here, maybe I'm looking to find the integral of x squared. Guess what? Hang on. Okay, so then I'm going to come over here. Okay, give me a second. 0, 1, 0, x to the 2/3, x squared. Hang on. dy dx. Did I copy that down right? I think so. So again, what I'll do is this first integral. Hang on. This first integral in each of these, and then I'll integrate that. Now, before I go on, okay. So this is actually the here, let's do it this way. Here. This will be the IY integrating. Okay, so what I'm doing is I'm taking the same integration paths on this integral. It's just instead of a y squared in here, I have an x squared. That is all that's different. Well, let's go through and look at this. Now it's a matter of just doing the integrals. And if I go down here, and I'll just enter them. Okay, again, I'm starting over. Hang on. I'll integrate. This time I'm going to integrate x squared. I'm doing this one right here, x squared. Integral values x. My definite integral is from y to brought up to the 3/2 power. And there's where I put the parentheses, and that's where I goof sometimes. And I hit OK. Now what I get out of that is something interesting like that. Now I need to integrate that, okay, from 0 to 1 dy. Integrate what I previously got, which this parentheses means take this equation, the output from the previous, and my integration variable is y dy now. And I'm integrating a definite integral from 0 to 1. And what do I get? 3/11. Okay, hang on, let me look. I think that's the correct answer. If you bear with me for a second. Ooh, you know what? I can do it this way. Maybe I can't, but I can sure try it. Let's see if it figures it out. Yep, that's the correct answer. Okay, so this showed to be 3/11. Now let's do the integral this way. Again, I'll do this one first and then take the answer and do this integral around it. So now, instead of moving there, I'm going to move it up to here. So I'm essentially starting over. I'm integrating the term, which is x squared. The integration variable is dy now. All right, and I'm definitely integrating between 0 and x to the 2/3. And there's my extra parenthesis again. Okay. Now, it's interesting. I get like 8/3 there. Now I'm integrating that. Okay, hang on. I'm going to integrate that. Percent means take the previous thing, which was x to the 8/3. I'm integrating with respect to dx right here, and I'm integrating definite integral from 0 to 1, and I get 3/11, which again is the correct answer. So we did that for those. Now, now I'm going to go ahead and find the other problem I was talking about. So here, this is kind of split into two. But this concept of which way you're sweeping first is pretty important. Now, let me go find the more complicated problem I was looking for, and just bear with me while okay. I thought I had it assigned. I did not assign it. So now, unfortunately, I gotta go find it. Okay. Well, maybe I did assign it. Give me a second. And maybe I didn't assign it. What happened here? Oh, wait a minute. I don't know. Let's just kind of try to make something up as best I can. I don't know. I hate to do that, but let's do this. Oop, that is not where I want to go with this. Here. Let's say I had an equation which is y is equal to x. And then I had an equation that was y is equal to x squared. Now, what's interesting is if I pick one, they're the same thing. And the reason I'm doing this is because this is one of the easiest ones to do. So this is the quadratic y is equal to x squared. And this is 1 and 0 and 0 and 1. And let's say we want to know, first of all, let's say we want to know the location here. Okay, so we want to know the centroid here, x bar, say. I don't know. Say this is x and this is y. So now the x bar is going to be somewhere out here. And I want to know y bar as well. So I want to know this integral. He says x bar dA. He has a little hat over the integral of d area. Okay, so again, here's the deal. As we look at this, you have to decide which way you're going to sweep first. To me, I would sweep this way. And as I'm sweeping this way, the first integral, hang on. So essentially I'm saying, what is the d area? I'm going to start here, and I'm going to move to the point where I'm eventually solving for the I bar. But here's my integral. Okay, hang on. So I want to know my area. My area is going to be a double integral of dx dy, right? But which one am I sweeping first? I am actually sweeping y first and x second. Here's what I mean. I'm sweeping from here to here, up y. This is the lower limit of my sweeping, and here's the upper limit of my sweeping. Okay? So if I look at this thing real close, I'm going to end up with a situation where I have swept from the, and I'm going to do this the other way too. I'm going to sweep from, okay, the lower limit on here. This is the lower. I'm doing this real slow, and the lower limit is y is equal to x squared. Here, hang on, switch pens. X squared. The upper limit being this one. Here's your upper limit, and it is x. Now, how far do my sweep lines go? They go from 0 to 1. Now, I'm not even going to do this yet until I decide that I'm going to, oh man, this is going to be bad. How do I do this? I know. I'll just, oops, that's not how I'm going to do it. Here's how I'm going to do it. I'm going to copy the whole thing. Oh no. Okay, copy. And here I am. On this next window, here's what I'm going to do. I don't know why it's doing this. Okay. Okay, so on this one, I'm going to get rid of these internal blue lines that I've got. And, okay, this time, I'm going to sweep this way first. As I sweep this way, what am I doing? I'm doing the same area integral, but this time I'm sweeping x first. I'm sweeping this way. Again, I'm taking my little delta x, delta y, dA cubed, and I'm sweeping it across there. Okay, so as I sweep it across there, what am I sweeping it from? The lower limit. The lower limit is this line right here. The lower limit being x here. Let me go back to my purple. X. My upper limit is this one now. Upper limit. Okay. Okay. Now, here's where I've got to do this. Okay, let's see. How am I determining my lower limit? My lower limit is a value x, which actually needs to be this, and this needs to be y to the half. And this needs to be swept from 0 to 1. Okay. Okay, so let me rephrase this. When I'm sweeping from left to right, and say I'm sweeping on this particular sweeping location, I need to know the x value, the x lower limit, and the x upper limit. The x lower limit comes from this equation, which is y. The x upper limit, x upper limit comes from this equation, but it is y to the 1/2. So that's why these are listed this way. Let's look at this and see if these both give us the right answer, or the same answer. Since I made this problem up, so let's start here. I'm going to start slowly. Let's see, go calculus, integral, starting this. I don't have anything in there. So if I have nothing in this little area, I just put a 1 in there. I'm doing dy, and I'm doing a definite integral, and I'm going from x squared to x. Okay, give me a second. X squared to x. Produce that integral, and I wish he wouldn't do that, but you have x minus x squared. Now, that is this part of the integral. Now I'm going to just do the remainder, which is calculus, integrate, take the percent, dx is my, and I'm integrating from 0 to 1, and I get 1/6. Okay. Now let's do this lower integral. Okay. It should be entered completely the reverse way, but here, we'll go ahead and calculus, integrate. We're going to integrate a number 1. The integration variable is x. We're definitely integrating definite integral from y to y to the minus half, y brought up to, and here's where I always have my trouble. He gives me that thing for me. Okay, so what do I get there? I get that. So that is this. Now I'm integrating that, simply dy, and I will do my calculus again. Integrate. The previous, the percent sign means integrate this from the y will be a definite integral from 0 to 1, and I get 1/6. So I get that. Okay, now I want to know x bar. Let's start this way. Okay, I can do either one of these. So I want to know x bar. So here's what I want to know. X, I'm going to integrate x. So what I'm going to do is I'm just going to take this equation just as it sits. X, so in other words, here's what I'm doing. 0 to 1, I'm simply copying this with an x in there. Hang on. Dx, dy, and lo and behold, I forgot to put my x in there. So here's my x. I'm going to do the same thing over here. I'm going to copy this, and I'm going to stick the x in there. Okay, so I just carry out these two integrals and see what I get. Again, I should get the same number because it's the same thing, but we need to really know that. So let's go ahead and do the calculus. Now, we could do this in one step, but I don't want to do that right off. So I'm going to integrate the expression x. The integration, I'm going to do this one first, right down here. I'm definitely integrating between y and y and y brought up to the, there's my extra parentheses, and I integrate that. Did I get something out of that? There we go. Got the first thing is this is the integral of this term right here. Now I just need to integrate it. The previous term, so percent means take this previous output. I'm integrating with respect to y, and the definite integral goes from 0 to 1, and I get 1/12. Do I get the same thing here? Let's see. This, again, this is a check. I should get the same thing, okay? So calculus, integrate. I'm going to integrate the x, but this time I'm integrating, the variable of integration is y. Now, I definitely integrating x squared and x, and x, and, okay, now I got an intermediate result here, because that's the integral inside here. Now, I've got to integrate that. Come on. Okay, integrate percent means the previous expression right here. Integrating with respect to x, and 0 to 1. And it's, again, 1/12. So guess what? If I want to know x bar for this thing, it's the integral. Hang on. Which actually, he has it written like this. dA over the integral of dA. That's right. So what I get is I get 1/12 divided by 1/6, or I get 1/2. So that's my x bar. That kind of makes sense. Okay, so now what would happen if I'm looking for here? Well, okay, we'll do one more. I don't even know how long I've gone so far. Hang on. Let me check that. I've gone 30 minutes, but some of those minutes were dead minutes. So let's keep going. And what you're going to see next, let's go ahead and do this. I'm going to do this, except I'm going to put a y in there, dx dy. So now what I'm doing is I'm going after looking for y bar, which is equal to integral of the y dA over the integral of dA. Well, I already know that that 1/6 is the lower thing. So I'm going to basically integrate this now. So I can just ask myself, okay, x is halfway. I'm pretty sure. So from what he's saying, I think my centroid should be about right here. So he's saying that's a half. But if this was a half over here, it'd be up here. So this really isn't going to be a half. I think it's going to be down lower than a half. Let's check it. So if we check this, so what we're doing is we're just going to integrate this thing. And then guess what? I'm going to grab this up here and integrate it off of this one as well. I wasn't going to until I really want to have a check for myself. Y dy dx. So I'm going to do both these integrals just to check each other. And so here we go. We'll do the lower one first. And the lower one, we integrate the expression is y. The integration variable is dx. The definite integral goes from y to y. Goes from y to y, brought up to the 1/2, and there is my integral on the inside. So this is an integration of this term right here. Now I'm going to do my second integration. Again, now my integration variable is y. I'm integrating the percent, which is the previous expression. I'm going to integrate respect to y. I'm going to do a definite integral, and I'm going to go from 0 to 1, and I get 1/15. So this will be 1/15. I have to check this to make sure that this is still 1/15. So let's look over here, and I'm going to do integrate the expression is y, my integration variable is dy, and I'm integrating from x squared to x, and I get that. So, okay, I get that. So now I'm going to integrate it. The variable of integration now is dx, the last term here, and I'm integrating from 0 to 1. And what do we get? 1/15th. Yeah, so 1/15th. So now, if I want to know y bar now, it's equal to the integral of y dA over integral of dA. The top term is 1/15th. The bottom term is 1/6, which is 6/15th, or I can scratch that and say 2 times 3 over 5 times 3, or 2/5, or, 0.4. So, yep. So, in fact, maybe this was 0.5. So the actual thing is down here at 0.4. Now, you get the drill. The drill is pretty simple. I mean, your biggest issue is coming up with the limits that match this. What happens in the middle doesn't matter. So I can simply do this. I can simply copy this sucker, do a copy, and I'll just drop right down here. And what do I do now? I do something really, there's that thing again. Can I do that? Get rid of it. Yes. Okay. Okay, I just square it. That's it. If I'm squaring it, then it becomes Ix. Notice that this and this are actually opposite. So that's that. So I've done this. I've done this so many times now. It really doesn't matter. So now, and here I don't have to think about these weird, funny bars he's got. So I just go in, I do an integration. I'm integrating. What is my expression? My expression is y squared. I'm integrating it with respect to x. My definite integral goes from y to y. Goes y to y. Right up to the 1/2. Oh, there's my extra thing. Okay. And that's what I get. Now, I have to integrate that because that's the center term right here. That's this. I'm integrating that term. Again, in this thing, it's the previous term with respect to y. And it's a definite integral, and I'm going from 0 to there, and I get a value of 1/28, I think. Yeah. Now, the question is, can I check that? Well, yep, I sure can. Here's the way I check it. I'll just grab this one, and I know my handwriting is not that great. That I apologize about. Okay, so I will do a copy there. Do escape. I'll go ahead and put it right here. Okay, there it is. Okay. So what is it that I'm doing now? I'm doing Ix. Well, what is Ix? Y squared. What is that? Okay, let's carry out this integral. Okay, hang on. I do calculus. Integrate. What's my expression? It's y squared. Now I'm integrating with respect to dy, and it is a definite integral from x squared to x. X squared to x. And that's my term. A funny term right here is the integral of this center section here. Now what do? I integrate it, the second term, percent. I integrate, percent means grab the previous expression. My integration variable is x. I'm integrating from 0 to 1. And what do I get? Lo and behold, 1/28. What is it if I want to do? Okay, pardon the expression, but I'm going to grab this, and I'm going to say, copy. I'm going to move down a little bit. I'm going to drop it right here. But this time, somebody says, hey, what is the IY? Guess what? X. Let's do this. We've got two of these. They should match. Just go straight in. If you're getting bored by now, you are in there with me. But here, let's complete this out. X squared dx, definite integral from y to y brought up to, that is not a brought up to, 1/2. Okay, so there's that. That's the integral of x squared dx from y to y over this. So now we're going to integrate this. Okay, hang on, calculus, integrate, percent, previous expression, integration variable dy, definite integral from 0 to 1. What do I get? 1/20. Okay, is that what I get? I have my check. Is that what I get on the previous? Let's do this. This is the last thing I'm doing. Integrating dx, dy. My expression is x squared I'm integrating here with respect to dy. I have a definite integral, but I'm going from x squared to x. Okay, did I do that right? Okay, I'm integrating x squared dy from x squared to x. Yes. Now, at calculus, I'm going to integrate percent, the previous expression. I'm integrating it dx from 0 to 1. And what do I get? 1/20. So I think that I've done enough for explaining how and what you do to sweep through to do these integrals. What you can use is your previous knowledge of calculus to do this. You don't have to use this parallel axis theorem like he does, but next time we're going to talk about the parallel axis theorem in complete, and we'll go from there. So I'm pretty much done.